Hello, everyone, and welcome to this Learn at DLF tutorial on accessible designs for data visualizations. My name is Rachel Starry, and I'm the Digital Scholarship Librarian at the University of California, Riverside Library. So the learning goals for this tutorial are that by participating, you will become familiar with some of the best practices for selecting colors for charts, including distinguishing between color palettes and color scales, that you'll gain an understanding of 4 simple design principles for creating accessible data visualizations, and that you will be introduced to some specific tools and resources for learning more about color and accessible design. Before we dive in, I do want to preface this presentation with a caveat that data viz is a very broad field of research, and researchers are constantly performing new studies and expanding what we know, so the current state of knowledge is constantly changing. What I'll be sharing with you today in terms of best practices may differ from what you've heard or read elsewhere, and of course is biased by my own understandings of these topics. I say all of this to acknowledge that I do not speak for everyone with various color vision abilities or to claim that we all perceive visual information in the same way. I do hope that this information can serve as a starting point for all of us to keep learning. When we talk about colors in charts, we often hear the phrase color palette. But I want to start by calling out the fact that there are actually 2 kinds of color choices for charts, scales and palettes. And these 2 modes of applying color to chart elements are appropriate for visualizing different kinds of data. So color scales are what we use for sequential data, and we use color palettes specifically for categorical data. Sequential data is continuous numeric data that lies along a smooth continuum of possible values, for example, the numbers from 1 to 1,000,000, or more realistically, all real numbers. Categorical data, on the other hand, is data broken up into discrete values or categories. And most often, categorical data is text. For example, the days of the week and months of the year are both categorical variables with the discrete values, January, February, March. But in a data set about cars, for instance, you might actually have a categorical variable like number of cylinders, where the values are only 4, 6, or 8 for the cars in your data set. So even though those are numbers, they are categorical data. So we'd want to apply a color palette to them as opposed to a color scale. Let's look at an example to clarify this difference. So scatter plots, seen on the left here, visualize the distribution of 2 sequential variables. Again, sequential data is continuous and numeric. So in the charts here, we see that the scatter plots represent variables with a range of values from 0 to 1 on both axes. Bar charts, as in the example on the right side, visualize the distribution of a single categorical variable. You may also see grouped or stacked bar charts that represent multiple variables at once. But in this example, each bar represents how many instances of a particular category occur in the data set. For example, this bar chart is just an abstract example, but it could represent the size of different university library budgets. If we imagine that the y-axis is in millions of US dollars and the categorical variable contains the names of different US institutions. So to start with how we map color onto sequential variables, let's look at what color scales are. And to clarify some of the terminology I'll be using, I don't want to get too deep into color theory, but in general, every color, with color in quotation marks, can be described in 3 ways. We can talk about hue, brightness, and saturation. So hue, H-U-E, is what in English we typically use the word color to denote. That is whether something is more red, more blue, or more yellow. Brightness refers to just the lightness or darkness within a particular hue. And saturation is how intense the color is. Is it a very saturated, vibrant blue, or is it a more muted, neutral color? So for our purposes today, we'll be focusing primarily on hue and brightness values. So in essence, a color scale is simply a gradient. That gradient can be composed of different brightness values across a single hue, as in the color wheel here on the left, or the gradient can be composed of different brightness values across multiple hues, typically 2 to 3 adjacent colors on the color wheel. So here on the right, we see a color scale that starts with white at the center and moves to light yellow-green, medium blue-green, and then dark blue. You may have seen examples of color scales like these. So choropleth maps represent the geographic distribution of, again, sequential values. So in this example on the left, the darker colors on the scale show where the highest data values are concentrated. A heat map is the same concept, allowing us to visualize where in terms of two sequential variables, the highest values or hotspots are concentrated in the data. And while the choropleth map uses a single hue color scale from light to dark green, this heat map on the right side of the screen uses a different kind of color scale that we'll look in more detail on the following slide. It moves from green to black to red. So when you take two gradients and put them together with a color like black or white in the middle, that is called a diverging color scale. So this is a variant of color scales used specifically for sequential data, where the values are spread to either side of a central value or midpoint. So common examples of this kind of data include financial values above or below $0. So we talk about being in the red when you have negative dollars versus in the black when you're above $0. That's a literal description of the colors commonly used for budget graphs. Diverging scales are also used for political views in a two-party system. So the cartogram here on the right is similar to the choropleth map we saw previously, but the geographical districts are abstracted. So this is from 538's 2018 forecast for the US House of Representatives election, depicting how strong the support leaned in different districts for each party, using the two gradients of dark to light blue and dark to light red. So moving on to color palettes, these again are used for discrete or categorical data. While color scales represent a range of values within one or a few adjacent hues, the goal for categorical color palettes is to make each category, each color, visually distinct so that readers of your charts can look at one data point, whether that's a line, a bar, or some other chart element, and immediately identify the category. Right away, though, I want to note that none of these are actually good examples of color palettes. We'll look at why that is in a few minutes, but these do illustrate really well how hue and brightness come into play as we select the colors for our palettes. So on the left of the three color wheels here, we have an example of a 5-color palette that uses hues that are adjacent to each other on the color wheel. And they're all about the same brightness value, right? So they're all kind of medium darkness values. This makes for a very aesthetically pleasing palette, but it's pretty terrible for a chart because all those colors are way too similar to each other to be easily distinguishable. In the middle here, we have a color palette that's a little better. The hues are spread out around the color wheel, which is what we want. That makes them more distinct from each other. But again, the brightness values are all fairly similar, except the yellow, which is actually just a naturally lighter hue. And on the far right color wheel, we again have hues that are adjacent, but here the brightness is varied across the hues, which makes it possibly the worst of the three example palettes, since the three darkest values are virtually impossible to distinguish from each other. Again, none of these are accessible examples, so now let's look at what is involved in selecting accessible color scales and palettes for our charts. Let's look first at best practices for creating accessible color scales. First of all, it's generally a good practice to limit the number of colors you use to 7, or ideally fewer. This is an area where you will see a lot of different numbers being thrown out by different people. Some researchers say 12, some say 5, but in general, fewer is better. And some of the most recent research suggests that the human brain really has trouble distinguishing more than 6 or 7 colors in one context. You also want to follow established conventions. In particular, dark colors are typically equated with high values, and light colors have come to mean low values. You should not reverse this scale. So in this example, choropleth on the left, the creator has reversed the scale and mapped dark colors to low values, resulting in a map that looks like the population of the US is concentrated in the northern Midwest and in the West, which is obviously not true. California and Texas and New York have the highest population. So this is bad. People expect dark colors to mean the highest values. So be careful when selecting hues for your gradients, particularly if you're creating a multi-hue scale, as we see here, because some hues are naturally lighter or darker than others. For single hue scales, you'll want to select brightness values that have high contrast to each other. Not only is this important for people with various color vision abilities, it's also necessary to pass the print in grayscale test, which is, if someone printed your chart in grayscale, could they still distinguish between the different colors? For multi-hue scales, you especially want to select hues that are visually distinguishable by folks with color blindness, Especially avoid blue to green, purple to red, and yellow to pink gradients. And finally, for diverging scales, you definitely want to select hues that are visually distinguishable by folks with color blindness, and this especially means avoiding combining red and green gradients, although you'll want to be careful with the other pairings mentioned, as some folks can't easily distinguish between blue and green, purple and red, or yellow and pink. Many of the same best practices apply to creating accessible color palettes. Like scales, you'll want to stick to about 7 or fewer colors. Select a range of colors with different brightness values so that they contrast with each other, enough to pass the print and grayscale test. And again, select hues that are visually distinguishable by folks with color blindnesses. Let's look at one tool that is exceptionally helpful for this process of selecting accessible color scales and palettes, primarily because it has built-in color simulations to help you see how your selected scale or palette might appear in different kinds of charts and appear to folks with red-green color blindness. So this tool, this palette, was designed by Elijah Meeks and Susie Liu. It links to 3 additional websites where you can generate color scales and palettes. Chroma.js is useful for making sequential and diverging scales. Color Brewer works with both scales and palettes. And Categorical is the most highly customizable option, and I recommend just checking it out and experimenting with generating different scales and palettes. VizPalette was designed primarily for web developers and for copying and pasting in JavaScript. But if you scroll down, you can change the colors in here manually, and you can export your colors as hex values, as RGB values, and as HSL values for use in different kinds of tools. So the primary functionality I want to call attention to in this tool is how it lets you preview the possible accessibility of your selected scale or palette. So over here in the colors and actions side of the tool, you can preview how your colors might look on different kinds of charts. It also lets you see if any colors are indistinguishable from each other as lines or points, medium areas, or large areas. If you scroll down here to the color report, anytime they flag colors as being difficult to tell apart, it will appear here in the color report. You can also preview how your colors may appear to folks with different kinds of red-green color vision deficiencies. And in this case, their default palette, you can tell for certain kinds of red-green color blindness, some of these colors are very difficult to distinguish. And if you scroll down to the color report, this will confirm that some of these colors will want to be swapped out to make this a colorblind safe palette. You can also simulate how your chart will appear or your colors will appear in grayscale. So again, these hues do not vary enough in terms of brightness values, especially some of these darker colors down here. And if you scroll down again to the color report, that will confirm that these grays and some of these grays, some of these colors do not vary enough in terms of brightness value to be able to tell apart in grayscale. So you'll want to consider swapping out those colors for hues that vary more. So the last part of this tutorial, we'll move on from color to look at 4 general principles for designing data visualizations that are accessible to all audiences. The first principle is simplicity. In general, displaying fewer marks or elements on your charts is better. We've all seen that terrible pie chart that has 40 incomprehensible slices, or those spaghetti line graphs that are essentially unreadable. There are strategies to make charts that need to have lots of elements more readable, such as using the color gray for all but the data points you most want to call attention to. But generally, be mindful of the purpose of each chart and look for ways to simplify it so that it's easier to read at a glance. In support of this, sometimes it's tempting to use more complex chart types, but in most cases, it's better to stick to charts that are familiar to folks. That said, I'm not advocating for avoiding less common charts that convey information really well. An example of times when it might be worth using a less common chart, here we see how the dumbbell charts on the right, though they may be less immediately recognizable, do a much better job, even at just a glance, at representing the differences between the 3 values than the pie charts on the left. The second principle is context. It's incredibly important to use clear descriptive text across your charts, but especially in the titles and captions, so that you can provide your readers with the context for what the chart is actually telling us in terms of patterns or relationships in the data. Additionally, it is critical that wherever you share a chart in electronic form, whether that's in a presentation, in a document, or online, that you describe your chart in the alt text field for that image. Charts and maps count as images, and they need to be described with alternative text so that folks with screen readers, or in the event that the image cannot be displayed, that text is available. So these recommendations for writing alt text come from a slide deck by Whitney Quesenberry, linked here, who states that if your image contains text, repeat the words. If it contains visual information, explain it. And if it contains sensory information, describe it. All of these are great guidelines for charts as well. You can use a descriptive chart title or caption. You can summarize the key takeaway of the chart, or summarize what patterns in the data are being visualized when you write your alt text. The third principle is legibility. It's important to ensure that everyone can read the text and the data values in your charts. For charts with English text or other languages that read horizontally, keep all your chart labels horizontal rather than pivoting them into a vertical or slanted orientation. Additionally, do not rely on chart legends. It's very important to directly label your data wherever possible. This is an example of a pie chart of literal pie, conveying the percentages that Americans consume of different pie charts. And here, the creator has directly labeled each of the slices. This is particularly vital for pie charts where it's fairly difficult for our brains to distinguish between, for example, a 5% slice and an 8% slice. Finally, the fourth principle is contrast. For all your chart elements, including the background and all text and labels, use colors that differ from each other on the light to dark spectrum, meaning they have a high contrast ratio. It's also a very good practice to avoid using color alone to distinguish between values. So where you can, also use elements like shape, fill palette patterns, size, or labels to help your readers distinguish between different data points. Here we just have an example chart demonstrating good contrast ratios compared to horrible ones. There are many resources available online for checking contrast ratios, and the Web Content Accessibility Guidelines that govern web accessibility are a good benchmark for contrast in your charts as well. So to wrap up, I do want to share just a few additional resources. The Data Visualization Checklist is a fantastic resource that helps you walk through and evaluate how readable your charts are. The Consumer Financial Protection Bureau has a great set of guidelines for data visualization, and the W3C Web Accessibility Initiative's recommendations are another great starting point. If you have any follow-up questions about this material, please do feel free to reach out. You can reach me at the email address on the screen. That's rachel.starry@ucr.edu. And you can find me on Twitter at the handle Rachel L. Starry. Thank you so much for engaging with this tutorial, and I hope it gave you some tools and resources for exploring more about accessible design in your data visualization practices.